My name is Steve Lambouses. I'm in charge of all of the battery management ICs for Texas Instruments. So these include ICs targeting something as small as a Bluetooth headset, all the way to smartphones, tablets, notebooks, power tools, e-bicycles, all the way up to electric vehicles and electric buses. So today I'll be covering a couple topics. We will focus on the smaller applications, the single cell, what we call single cell applications, like the smartphones. So the topics that I will cover today are trends in battery management that we see in the industry and the market and that customers ask for. And then I have two new and exciting product updates that I wanted to discuss with you today. One of them is wireless power, which I think many of you are familiar with. And the second one is a new technology that we're bringing into the market called MaxLife technology. And I'll get into some details on MaxLife and why it's important. So when we look at trends in the market today for battery management, we see a couple things. First of all, customers are asking for faster charge. They want to be able to charge their smartphone or their tablet or their piece of equipment faster. They also want it to be cooler charging. They don't want it to heat up. It's a bad user experience if the phone gets hot. People are concerned about safety. They also want more accurate capacity measurement. People want to know exactly how much runtime they have left in their phone. I came from Dallas this weekend. It was 14 hours and 30 minutes on a plane. If I'm playing with my smartphone, I want to know when I land, do I have 30 minutes left to call my family to say I've landed? That is accurate, smart, what we call gas gauging, fuel gauging technology that Texas Instruments has. We also see a trend in newer and higher capacity batteries. If you look at the recent release of the Galaxy and some of the newer smartphones, the battery is becoming bigger, more capacity, but it also has to become thinner. And so these are opposing. We see bigger batteries for more lifetime, runtime, but the size of the system is becoming smaller. And then, of course, a lot of customers asking for wireless power. Wireless power offers a convenience to be able to charge your phone anywhere you go when the infrastructure is built out. So I will address the last one first. So I would like to cover a little bit about the wireless power and TI's presence in the wireless power stage. So TI was the first to release what is known as Qi compliant solutions. So Qi is the standard endorsed by the WPC. WPC is the Wireless Power Consortium. It's a group of over 130 companies that got together in 2008, 2009 to help form a standard for interoperability. So anybody's phone can work with anybody's charging pad and vice versa. That's interoperability. So we were a founding member of WPC. Currently there are 2 released specifications, versions for the WPC. The first one is WPC 1.0, which was released in August 2009. And the second one, the newer one, is WPC 1.1, which was released last September. So all systems going forward need to be compatible to WPC 1.1 and backwards compatible to 1.0. However, we are also members of 2 other wireless power consortiums you may be familiar with. One is PMA, Power Matters Alliance, and the second is A4WP, Alliance for Wireless Power. So TI is also members of this. We're helping them complete their specification and to help them bring new products to market with the TI solutions. Today, TI has 5 transmitter designs released, and this is actually 7 receiver designs now released to the market. For those of you that may not be familiar with the wireless power system, there is actually 2 parts to the system. There is what is known as a transmitter, TX transmitter, and the receiver, RX. The transmitter will typically be built into a table or it will be a pad that you would leave in your office or on your nightstand next to your bed or in your kitchen. The receiver is built into your Bluetooth headset. It could be built into this pointer. It's built into your cell phone. That's the receiver. These circles represent coil designs for the transmitter. And really it shows a evolution of flexibility. The first design had a magnet in the center so that the receiver had to be placed exactly in a particular spot on the transmitter. Very close alignment with a magnet. As the specification and technology evolved, the magnet was removed from WPC, and they added flexibility so that you can place it anywhere on the pad and it would charge. This is very important when you're driving a vehicle because you are unable to look to see where placement is. You have to be able to just put it on the pad and continue driving. Because this technology is new and can be somewhat confusing or complex to some of the system engineers, we have developed a very extensive design support, documentation, training, and system support. So we have system engineers. We've done special deep dive technical training days with our field applications within Texas Instruments with customers. We have offered certified reference designs. In order to be compliant, CHI compliant, you must get certification, third-party independent certification, and we support that with our customers. We also support helping customers fine-tune the total system. You can imagine that trying to get the efficiency out of something small like this versus a larger smartphone would be a different challenge. As a result, we have several released solutions to the market, and over 80% of the CHI compliant solutions and products on the market today are using Texas Instruments solutions. So here is a small example of the CHI solutions released to the market today. These all use Texas Instruments technology in all of these solutions. The most recent being the Samsung Galaxy 4 that was recently announced. You can also see in here some of the carriers. So Verizon, of course, the Lumia 920 is exclusive to AT&T in the US. Docomo out of Japan was the early adopter of the wireless power. They were the first to launch with Texas Instruments in the wireless power technology. If we look at where we are today, we have demonstrated two-dimensional freedom. Two-dimensional being X and Y freedom placement. We've demonstrated that on a parallel surface with 5 watts of power. The WPC specification today is supporting 5 watts of power. We have demonstrated even higher power levels, 10 watts and above, to charge a tablet, but the specification, the consortium has agreed on a specification that only supports 5 watts. Next year, they will release a specification for compliance to 10 watts and above. Today, we have a 1-to-1 pairing. So when you place the receiver on a pad, it's a 1-to-1. What is coming next is multiple receivers on the same pad, a 1-to-many pairing. Today, there is a one-way communication. So the receiver talks to the transmitter, and it says more power, less power, stop power. In the future, next generation will be two-way communication. This gives the OEM or ODM flexibility now to talk back to the receiver for authentication, for other features as well. And of course, the near future will also include now the specifications from PMA and from A4WP, the Alliance for Wireless Power. Okay? So next I want to talk about fast charge and the user experience as a result of that. So when you try to charge a battery fast, you try to put a lot of energy into the battery quickly. And that can actually damage the battery so that the battery does not last as long or as many cycles. A cycle is defined as full charge, full discharge. So you may get a really fast charge, but after 1 month or 2 months, you will realize that the battery doesn't last as long anymore. That's because you're damaging the battery or degrading the life of the battery. So we know that mobile users get very frustrated because of that. Specifically, in the past couple of years, many of the smartphones are releasing with the battery embedded inside. So you cannot replace the battery anymore easily. So you have to find a way to charge fast, but also not damage the battery. And so we have done a lot of analysis actually from our experience in the notebook market. When the notebook space moved to embedded batteries, this was a problem that had to be solved as well. And so we are bringing that same technology to market in the smartphone space. So on June 6th, we will be announcing a new technology and family of products called MaxLife. MaxLife fast charging technology. So MaxLife allows you to charge the battery quickly, but also not degrade the life of the battery. And again, this is coming from our years of experience in the notebook space, our years of experience with different chemistries and technologies. So we allow for a fast charge and 30% longer battery life over what's available today. Our MaxLife gas gauge or fuel gauge accurately predicts and avoids the charge conditions that degrade the battery. So the fuel gauge knows everything about the battery. It knows everything about this chemistry. It knows everything that the battery has been through. It knows how many cycles are on the battery. It knows the temperature of the battery. And it can use that information to control the charger, unlike anything that's been done before. And so we have 3 new chipsets, gauge and charger chipsets that allow for up to 4.5 amps of charging. This is the most advanced technology out there for charging. This allows for a very fast charge, but again, without impacting battery life.
Improving longer battery life, does that mean that you will have more cycles, or will the runtime of the battery will be extended?
More cycles. So this is actual data taken with and without the MaxLife technology. So on this graph, the blue line is a low charge rate. This is a low charge rate, so a 0.6 C charge rate. So this would be a slow charge rate, and the x-axis is time. So this is 3/4 of an hour to get to a full charge. The red is a fast charge rate to rapidly charge the battery without MaxLife. And the red is actually showing on the y-axis degradation of the battery. So this is actually a measure of degradation or damage. The green is MaxLife enabled, showing you the same fast charge, but without degrading the life of the battery. So this is additional data from the laboratory about, again, standard charging and charging with MaxLife. The x-axis is number of cycles on the battery. So this data is for 100 cycles. So 100 times to charge and discharge the battery. This y-axis is what is called full charge capacity, percent of design. So this would be the size of the battery, the size that your system thinks the battery is. So after 100 cycles, you have lost 8% of the battery. So you can no longer use that 8% because you've damaged the battery after 100 cycles. A typical cell phone will see 400 or 500 cycles or more in its lifetime. So you can imagine this effect after 300 or 400 cycles. So the same battery after 100 cycles is around 95%. So you have more battery life left using the MaxLife technology. And again, same charge rate, same fast charge. We're just avoiding something called lithium-ion plating.
You avoided lithium-ion plating.
Yes.
That's MaxLife technology.
Yes, it avoids, because the battery is a cell, it's a chemistry, by abusing it, lithium ion starts to plate, and that's what actually damages the battery. So this is a block diagram of a typical system, and the battery management is the heart of the system. Every portable system requires a charger to operate. And what we're adding is the smart fuel gauge technology to control the charger, to optimize fast charge, state of charge accuracy, so the user knows how much capacity is left, and to also prevent the degradation of the battery. So when we look at the benefits of MaxLife, and MaxLife is a combination of a gas gauge and a charger, there are several benefits. One is what we call autonomous battery management. So the cell phone manufacturer no longer has to worry about what charger to pick, what chemistry, what battery. Some cell phone manufacturers have 15 different batteries that they use with their phones. We reduce all of that overhead because the gauge now controls everything. There's a higher safety and security because of this now. Because the gauge and the charger are autonomous and the system talks to it over I2C, there's no way for a virus or someone to hack into the battery to change the safety features, to change the charging. Unlike a host-controlled charger, this is completely isolated, and the gauge controls the charger and talks to the host system. There's also a big improvement in the power and heat dissipation. With a high-capacity charger outside of the traditional power management IC, we can do faster charging. We have integrated FETs. There's a BOM saving as well. And then, as we mentioned before, the improvement in lifetime, and then the longer battery runtime, higher accuracy from our gas gauge and our charger combination.